In this lesson, we're going to look at analyzing and sketching graphs. We can use what we learned about constant rate of change and linear functions, nonlinear functions, and kind of look at a graph and see what the relationship is between the quantities without using any specific numbers on our axes. So when we're looking at this, we're going to just basically describe what is occurring. So in this first example that we have distance here on a y-axis and time on our x-axis. So what you can see is that, all right, when you started your travel, the time increased. Then we kind of stopped here for a little while. What this could indicate is that we went to a rest stop or something like that where no change in time or no change in distance occurred, but change in time had occurred. And then our decrease here is that maybe we were going a little bit faster or a little slower, I should say, that our distance isn't as great as our time. But as we kept going, the value decreased about a lot. So we can look at graph and analyze what we see. So looking at these next two, they show the temperatures of two cities. So describe the change in temperature in each city. When you look at Belfast, Maine, you can see that your temperature increases as you begin your day, and then it slowly decreases at almost the same kind of rate. So when you say to describe the temperature change in each city, we can say for Belfast, Maine, that the temperature increases at the beginning of the day, and then it decreases for the rest of the day, and then it kind of like plateaus and then decreases for the rest of the day. So then when you look at Newport, Oregon, you can see that the temperature drops pretty quickly at a constant rate. And then it actually stays the same for a period of time, and then it slowly increases at a constant rate. So that's describing the change in temperature of Newport, Oregon. You can say that the temperature decreases at a constant rate, then it stays the same. So do that different color. Then it stays the same, and then it increases at a little bit of a slower rate. So making three comparisons from the graph, well, one comparison can be that they both graphs show an increase and decrease in temperature. Even though they're kind of reversed though. So like Belfast, Maine shows an increase and then a decrease. Newport, Oregon shows a decrease and then an increase. So both of them do show a decrease and increase. Both of them, so another comparison is that both are nonlinear. But Newport shows three different linear sections. So both graphs are considered nonlinear, but Newport does have three linear sections. And in Belfast, the last comparison is in Belfast, it was warmer at the end of the day than the beginning. In Newport, it was colder at the end of the day than in the beginning. So we can describe graphs without actually having any labels. We can also sketch them. So in this one, it says when you are sketching a graph, draw and label your axes, but do not put numbers in. Sketch the graph based on your information. So you're going to say, did it increase, is it decreased, is it constant? So distance versus time. Distance, because we're looking at it says a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while and then slows down at a constant rate until coming to a stop at the next station. So time is always your independent variable, always on your x-axis. So distance is going to be on your y-axis. So as time is going, it's saying that the subway train gains speed at a constant rate. So it's going. It's gaining its speed at a constant rate. I should not have this as distance. I should have this as speed versus time. So it's going, its speed is increasing at this constant rate. And then it hits that maximum speed. So it stays for a little while. And then it slows down at a constant rate. So you can see we can sketch a graph without any values or anything like that and just see what does it look like. So the last piece that we're going to look at is here, kind of like a recap. What I want you to do is I want you to pause this video. And then I want you to match the verbal description with the part of the graph that it describes. Unpause, and then you'll see the answers. So you can see that F is where it's staying the same. Slowly decreases at a constant rate is going to be C. Slowly increases at a constant rate is going to be A. Increasing at an increasing rate, that's going to be E. Quickly decreases at a constant rate, that's a super steep slope down, that's D. And then quickly increases at a constant rate, that's going to be B. So we can sketch graphs and analyze graphs without any values, just kind of by describing the way that they're going. Are they increasing? Are they decreasing? Or are they staying at a constant rate?